Yeah, is my screen visible now? MS Word?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, we'll use this otherwise. This also you must have to know. These are the program outcomes. You have joined the BE program at our college, right? So these are the program outcomes. After you finish your BE, what did you basically equip with? Fine, is what the outcomes of the program that you are pursuing now, right? So the first program outcome is the engineering knowledge. So how far you are good at applying the knowledge of mathematics, science, engineering, and fundamentals, and an engineering specification for the solution of complex engineering problems. There are certain competencies. Under each competency, you can find certain indicators, performance indicators, at the end of the course and at the end of the program, rather, right after 4 years of course. At every course, we calculate the attainments by measuring your results, and at the end of the every year, every semester, every year, and the entire course, right? So, which is going to be rather assessed by a team called NBA, National Board of Accreditation. You must have seen our colleges in NBA accredited, right? So college of NBA accredited, you must have to pay certain amount of extra fees that you have already paid, rather, right? Which included in tuition fees. And so these are based on the results that you obtain at the end of the course and program, and your attainments will be measured based on these parameters, and the outcomes will be judged by the committee and the team, rather, right, which visits our college regularly every after 3 years, right? So second one is problem analysis. How far you are good at identifying and formulating the research literature and analyzing complex engineering problems, reaching substantiated conclusion using first principles of mathematics, natural sciences, and engineering sciences. Then under which again you have certain competencies. Each competency carries certain indicators. So these indicators are going to be mapped to the course that you are going to study and that you have obtained after you pursued it, right? In terms of some measurable, quantity, rather, right? And program outcome 3, right? These PO1 to PO12 are common for all engineering branches, right? PO3 is design development of solution. How far you're good at designing the solution for complex engineering problems and design system components or processes that meet the specified needs with appropriate consideration for public health and safety and cultural, societal, and environmental consideration. Then programming outcome 4, how far you're good at conducting investigation of a complex problem using research-based knowledge and research methods, including design of experiments, analysis and interpretations of the data, and synthesizing of the information to provide valid conclusions. Then program outcome 5, the fifth program outcome, the modern tool usage. How far you're good at creating, selecting, and applying the appropriate knowledge, resources, and modern engineering and IT tools, including prediction and modeling, to complex engineering activities with an understanding of the limitations. Program outcome 6, the engineering and society. How far you're good at applying the reasoning informed by the contextual knowledge to assess the societal, health, safety, legal, and cultural issues and the consequent responsibilities relevant to the professional engineering practices. Program outcome 7, environmental and sustainability. Understand the impact of the professional engineering solutions in societal and environmental context and demonstrate the knowledge of and the need of sustainable development. Program outcome 8, ethics, which is also equally important. When you work, with different kind of people, right, with different cultures coming from our different regions, religions, areas, and so work ethics also more important, which you're probably going to learn as part of this course. How far you're good at applying the ethical principles and commit to professional ethics and responsibilities and norms of the engineering practices. Individual and teamwork, right? You may have to work sometimes in a team, or you may have to be, given as a work to do individually, rather, right? So how far you're good at doing all these things are going to be assessed during your entire course that you're studying here as part of your program, right? Functions effectively as an individual and as a member and a leader in diverse teams and in multidisciplinary settings. 10th outcome, the communication, which is more important in industry when you work with different kind of departments and teams, right? How far you're good at communicating the people and conveying conveying your requirements and getting it done through your subordinates and conveying the same to your boss and convincing certain things which probably he is not willing to accept it, rather, right? So how far you're good at communication? This is also more, important and equally important with your subjects, rather, right? So this is going to be, taught as part of every course, rather, right? Like by interacting with you or by giving some assignments, we communicate. You communicate with us, and the internal exams and counselings. We have a lot of events that we conduct at our college or department level. It could be cultural, or technical, or environmental kind, rather, right? So communicate effectively on complex engineering activities with the engineering community and with the society at large, such as being able to comprehend and write effective reports and design documentation, make effective presentation, and give and receive clear instructions, right? Then 11th outcome, project management and finance. This is also important, right, for your work life, right? You need to manage if you are given a particular project to carry out with a particular team, rather, right? And you have to at the same time see that it will be executed within the finance budget limits, right? The constraints that were being, instructed by your company or your boss, rather, right? So demonstrate how for good area, demonstrating the knowledge and understanding of the engineering and management principles and applying these to one's work as a member and leader in a team to manage project and in a multidisciplinary environments. And the 12th outcome. So these 1 to 12 program outcomes are common for all engineering branches, right? That is, the last one is the lifelong learning. See, what you are learning is going to be for lifelong. There are certain subjects, for example, if you are from AAA background, basic circuit analysis, right? Electrical circuits. These are some of the fundamental subjects which you probably learn required to be, remember forever and then adapt with the new changes that are coming up in that area, rather, right? It's a kind of lifelong learning, right? Recognizing the need for and have the preparation and ability to engage in independent and lifelong learning in the broadest context of technological change. Okay, so these are all the common for all the branches. So these are all the outcomes which you probably obtain with um, which are going to be measured at the end of the course. And all of you can see my word, right? MS Word.
Yes, sir.
Yeah. So here today we'll discuss about the block diagram of computer, right? What is more important in computer? Yes. What is more important in computing?
Motherboard. CPU, sir.
CPU, right? So I'm first trying the CPU here. What CPU stands for?
Central
Control
processing unit.
processing unit.
Yes. Central processing unit. You can draw the diagram as well. So you can find CPU. In CPU, you will find majorly three elements, right? There is a control unit you will have. There is arithmetic logic unit you will have. Then you will have memory unit, right? So here, the control unit plays an important role here, uh, which will provide the required functions and operands for the respective instruction, which is given as part of the program, right? So basically, what do you mean by program? Program, it is a set of instructions, right? It is a set of instructions to perform a particular task, right? Perform a particular task. Yes, sir. Perform a particular task. So this instruction, every line in a program is said to be an instruction, right? So an instruction can be like C equal to A plus B, for example, if you have, right? So this particular instruction, what it is saying that you have to perform an addition operation here, right? So operation is addition, then you have two operands, A is the left operand, B is the right operand, right? So after having been evaluated, the result which you obtain should be placed in C, right? So in order to carry out this instruction, you need some, function, right? So arithmetic logic unit, ALE stands for arithmetic. So it carries all different kind of operations. So it can perform all arithmetic operations like addition, subtraction, multiplication, and all. Then logical operation like and or not, exclusive or and all kind of thing. It consists of shift operation altogether, right? What all the operations as part of your computer you perform, they are going to be available as part of ALU, rather, right? And then you have CU. This is a control unit which is going to control the computer the other way around, I say, because it provides the necessary function for this particular instruction. For example, if you have this particular instruction in a program, so which particular circuitry will perform this particular operation. So in that ALU is a circuitry. At the beneath, if you see, it is the entire hardware, rather, right? So you have either circuitry, rather, right, which is going to perform the add operation. At the beneath, if you see, all the operations are going to be carried out through add only. Fine. Addition is the basic operation. Fine. So even if you have, for example, you have subtraction. How do you perform subtraction? Subtraction is a part of addition only, right? Subtraction, how do you perform subtraction is you add the 2's complement of subtrahend to the minuend, right? It means the complemented value of the subtrahend will be added to the minuend. It means you are performing addition itself, even in the subtraction. If you go for multiplication, it is also addition, rather, right? Shift and addition. It's a combination of shift and addition. If you see division operation, it is also it is also a mix of addition operation only. Fine. It's a combination of addition and complement and then shift. Fine. Because in division, what do you perform? You perform subtraction and shift. But subtraction is a combination of addition and complement. It means for all such operations, addition is the basic operation. Fine. So the CPU performance will be measured in terms of the adder circuitries, rather, right? So the analyzers, the CPU designers, when they design, they measure the performance of CPU throughput by taking some of these parameters, rather, right? So anyway, ALU is going to perform all arithmetic and logic related and shift and all kind of related operations. Control unit, what exactly it does, when it finds that there is an instruction to perform addition operation, it will enable the adder circuitry in this ALU, and then the operands are required A and B, which it will take it from memory, right? The operands will be stored in the memory. Memory unit carries the set of registers. You will have registers, right? So all these operands will be stored in the register in the memory, rather, right? So these operands, which are stored as part of the memory unit, will be taken for the operation, and the operation will come from the ALU, rather, right? So who is managing all this? Who is providing the data required in order to carry out this particular instruction given by the user? Control unit. So control unit will communicate with both ALU and MU, right? ALU and MU. And then it provides the necessary operands required for that operation, necessary circuitry to be enabled in order to carry out that operation, right? But the user is going to give the program and its data through the input device, rather, right? So input devices are also very much essential, right? So if you see input devices such as keyboard, you generally write your program through the keyboard, or some other input devices like you have a scanners, through scanner also you can send, or you have joystick, right, and all kind of thing, right? And then output devices where the output is going to be printed, generally on the console or the monitor, right? And the printer, sometimes you can probably use printer also to take the output and all kind of thing, right? So this is the block diagram of the computer. This is even said to be the von Neumann architecture, right? Von Neumann architecture. This is the architecture based on which the subsequent architectures are built, of course, right? Okay. So if the question is asked von Neumann architecture also, you can do the same thing. You can write the same answer for the same block diagram of computer. If asked von Neumann architecture, you can give the answer, the same answer, right? So here, I hope this is clear to all of you, the block diagram of computer. Fine?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So now, as I said, we are going to provide a program, fine, as an input to the CPU and the operands, right, or the data, rather, right? So here the computer device, shall I erase this? Shall I erase this? Yes, I'm erasing. Yeah. So in general, if I just consider computer as a system, right? Computer is an electronic device which performs the user's task, I say, right? Any system, if you take, it will take certain inputs and provides you certain outputs, right? For example, educational system, if you take, right, MVSI Engineering College, you have joined, fine. Here you will be going through the different courses, fine, that is nothing but your program, right? Then the outcome, see what is the input given to the MVSI Engineering College EEE department? An intermediate student, right? A student who is willing to learn. He has undergone the program, EEE program. Then what he will come out as? A EEE engineer, right? That is the output, right? So any system in the real life you take, it will have certain inputs and produce a certain output. Similarly, if I take computer as a system, it will take certain inputs. What are the inputs that it takes? Program and data. It will take program and data, right? And produces what? The output, which is nothing but again a data, right? So if you see the system, it's taking data and producing data. If you see in the system at the beneath, you find the entire thing is the data itself. That's the reason why sometimes we call computer as a storage device where you can store some data, right? Data is being stored in the form of binary form, of course, right? Fine. So now if I define, the program, I say it is a set of instructions that enable the hardware or electronic device. This is an electronic device, right? Computer or electronic device to perform required task. Yes? Can you see now the definition? I have given second definition of a program. Am I audible?
Yes, sir.
Yes, sir.
Yes. So now I have given another definition for program. Now I'm saying that it is a set of instructions that enable the hardware or the electronic device to perform a required task, right? See, the computer is an electronic device. It's a hardware, if you see. Unless there is some program which enables its devices, fine, that computer will not go to perform any required task. Fine. So whatever you want to get it performed through the computer, you need to frame it as a program and then give as an input to the computer, right? Now coming to program, how do you write the program is what the more important thing, right? In the entire, computer science. So writing a program and then guiding the hardware or the electronic device to carry out our respective task or required task is what going to be given in the form of the program. What am I? So now, before writing the program, what we do is we will write algorithm. We need to write an algorithm. Fine. See, you want to, let us say, for example, do some simple calculation like addition of two numbers. So how do you perform addition of two numbers? You need two operands. Operand is nothing but carrying some data. Fine. So two operands. So on that two operands, you perform addition operation. But then to perform addition operation, what all are the things which are required rather, right? You need to first identify you need to first analyze, fine, and then you need to identify what are the inputs in it, and what computations you need to perform, and what is the output out of the same, and that output how you are going to present it, rather, right? So you can see there are certain phases which are mandatory while writing the program. Fine. So before writing the program basically when I write with respect to C syntax, I say it is a C program. If I write the program with C++ syntax, I say it is a C++ program. If I write that program with Java syntax, I say Java program. But before writing it with respect to any syntax, before that I need to make few things clear, that the program consists of what? What are the steps that I need to carry out in order to execute my particular task, right? That is my more, aim behind that, right? Before I go for writing the program, right? So now here, how do I do that? By representing it as an algorithm. Algorithm is a step-by-step procedure, right? It is a step-by-step procedure, fine, to perform a task. You need to perform. You'll be first identifying that what instructions and what should be the sequence of instructions, right, in the algorithm. For example, when you want to go to college, how do you start? You first wake up and then brush up and then take a bath and wear your clothes, then you take your food and then start. You can't. You don't do like you wear the clothes and then go for bathing. You don't do that, right? First you take your bath and then you wear the clothes, right? So the sequence is more important. The sequence in which if you can probably represent or execute the instruction, you can be able to reach your goal. You will be first, judging and then representing the same in the form of an algorithm, right? So, for example, addition of two numbers, when I am talking about, how do I write an algorithm for it, right? Addition of two numbers, for example. But you need to identify here, first of all, what are the variables, and what are the inputs in it, and what computations you need to perform, and then what is the output out of it, rather, right? Shall I clear this?
Yes.
Yes, sir.
Yeah, so I'm writing here algorithm. For addition of two numbers, let us say, right? So I just say algorithm add. Fine. Then this is the beginning of the algorithm. I can give open brace, or I can say begin also, no issue, right? You can say begin as well. So to perform addition of two numbers, I need three variables, right? I have identified that the three variables required. And what should be its type, data type? Fine. What kind of data that it should carry also I need to identify before. So let us say they are integers. Then what I do first, I will declare the variables required for me, right? Declare A, B, C as integers. Then I need to identify what are the inputs in it, right? I want to perform A plus B, then A and B becomes the input for the same, right? So I need to read the inputs, read A comma B, right? Then I need to perform the addition. For that I need to do some computation. So I say calculate C equal to A plus B, okay? The output which I obtain is C, so which I am going to print. say print C. Then you end the algorithm, right? This is how I write the algorithm, simple algorithm. Now, if you see, there are certain steps which I have done in particular order or in a sequence. If I miss that sequence, then my program doesn't work. I can't say it's an algorithm, rather, right? So first thing that I have done is the declaration. This is the declaration. What is that I have done first? I have done the declaration. So declaration is the first part I have done. Yes or no? So by identifying what all the variables required in your program, you first declare them, fine, with certain data types based on your requirements. So that I have done first. Then what is the next thing that I have done? I need to identify the inputs out of it. Inputs are A and B, so I have read the inputs. So second part that I have done is nothing but initialization. Initializing the inputs. Yes or no? So I say initialization, second step. Then what is the next step that I have done? I have done the calculation, right? Here I can see there is an arithmetic operation. In case if you have some logic, then it could be some logical operation, right? So what are the computations that are needed as part of that particular respective task to be carried out? We are going to mention all that respective operations here in the next step. It means the first step should always be a declaration. It means what all the variables that you need to use in your algorithm or program have been identified with certain data types, have to be declared first. Then you will be initializing the inputs. You have done that. Then the other way I can say initializing the variables, right? Then the next thing that you do is the arithmetic and logical operations. What all required you will be performing, right? Arithmetic, logical operations. Yes or no? So next step that you have done, right? First thing is you have declared. Next thing is you have initialized. Next thing is you have calculated. So that comes under arithmetic operation here. Next step is nothing but the displaying the output. What is the output here? C you are printing, right? So displaying the output or printing the output, right? So we can say displaying the output. So you can see these 4 steps in the same sequence in any algorithm or program. And you can consider these are the 4 benchmark steps that you find in every algorithm and program. The first thing that you do is the declaration by identifying all the variables that are needed to be used in that particular algorithm. You do it. Then next thing is you identify the inputs that are required. Then you initialize all such variables. Secondly, next thing that you do is the arithmetic or logical operations. What are needed you will be carrying out. Then you are going to display the output, right? Or print the output, right? How we have printed here. Fine. So these are the 4 steps, and it should be in the same sequence you can find any algorithm or program. Got my point? Now we will move to write the program for the same. If before writing the program, I will even show you the flowchart as well. Is this clear till here? How to write an algorithm?
Yes, sir.
Yes, sir.
To add 2 numbers. Algorithm to add 2 numbers. You can note it down while I was writing. Right. I'm clearing this. Fine. So you can see algorithm is going to be written in simple English, right? Which is understandable by any novice person. It means the person who does not know the programming language also could be able to understand. That is the aim behind writing the algorithm. Fine. Anybody can understand. Fine. So algorithm, sometimes you find it as simple normal English sentences, or you can find it as a pseudocode or mnemonic code. Fine. or mix of both, right? Sometimes. So that is what you can see here in this algorithm. I can, instead of begin, I can say open brace also, because there are certain people who will write the algorithm like Goodrich, Tamasia, he use open brace and close brace. Some will write begin and end. So algorithm, there are no restrictions. You can use any notations here, right? As I said, it could be mix of the simple English and the mnemonic code. Fine. Now, flowchart, right? So what do you mean by flowchart? Flowchart is, it is a pictorial representation of an algorithm. It is a pictorial representation of an algorithm. Why do we draw the flowchart? Even the person who does not know, fine, English as well can be able to understand, or that respective language in, or that user level language which you have used. Any child can be able to easily understand, right, by looking at the flowchart. So if basically these are all being followed in the industries. Why? Because the higher officials, they don't have much time to go through the entire written part of it, right? If it is in the form of a diagram, you can just look at the diagram and by going through the steps, he can understand what is going on. So that is another reason why the flowcharts are also being used, right? So flowchart is a pictorial representation of an algorithm, you can say, right? So with the help of which any person can easily able to understand what is going on there, right? Correct. So any child can able to easily understand. So what are the flowchart symbols? You can write down while I am writing here. Flowchart symbols. We use oval for start or stop, stop or begin and end kind of thing, and we use parallelogram for input and output kind of thing, reading or printing kind of thing. Then we have rectangle. This is rectangle. So this is being used for declaring the variables, that is for declaration part, and as well for arithmetic or logical operations. And we will have diamond box. This is being used for testing the conditions, right? If you have some dot conditions, right, or conditional statements, you can use this, right? And if your diagram is exceeding the page, and you have to draw the part of that flowchart on the next diagram to connect diagram from one page to another, you can use this connector. Fine. Circle as a connector. So these are the flowchart symbols. You please note it down. I hope all of you have noted down. Shall I move? Shall I erase this? Yes.
Yes, sir. You can.
Shall I erase this?
Yes, sir.
Yes, sir.
Yes.
Yes, sir, you can.
Yeah. So now we will draw the flowchart for addition of two numbers, right? Flowchart for addition of two numbers. So in algorithm, what is the first step? Begin was the first step, right? So here begin is going to be represented with start symbol, right? Then what was the next step in the algorithm? That was declaration, right? You were declaring A, B, C as integer, yes or no? So for declaration, what do you use? Rectangle, got it? And what is the next step you have? You have read inputs. You have read the inputs like A and B, right? So for input and all, what do you use? You will use parallelogram. What is the next step you have there? C equal to A plus B, which is nothing but arithmetic operation. For arithmetic or logical operation, again, what will you use? Rectangle. Got it? So C equal to A plus B. What is the next step you have? Printing the output, right? So what is the output here? You got C as the output, right? So you are printing C, yes or no? Then what is the next step that you have? To end the algorithm, right? So what do you say? Stop. STOP, stop, using parallelogram. Is this clear to all of you? Now I hope this is clear to all of you. You can write an algorithm for a given task and you can transform the same into the flowchart. You can see the steps from algorithmic point of view, right? Algorithm, add, it was there, right? You have first step is begin. So for begin, what did I say? Start. What was the next step? Declare A, B, C as integer, right? So that I have done here, right? Next step, what was the next step? Reading the inputs. A, B, read A, B, read A, B. This is how I do it. Then I have another step is C equal to A plus B. How do I represent the same in the flowchart? Like this. And then print the output, right? So how do you represent printing? With the help of parallelogram. Then you end the algorithm. When you end, what do you say? Stop, right? With the help of parallelogram, sorry, ellipse, right? With the help of ellipse. Start and stop are represented with the help of ellipse. I hope this is clear. The mapping between the algorithm and flowchart. Yes? It's clear?
Yes, sir.
Yes, sir.
Yes. Now we will write the program for the same using C language. So if I know how to write an algorithm and to represent the same using flowchart, fine. Most of my work is over, right? Problem solving technique is over. Second part. Problem solving technique is over. Now coming to the first part, program, right? Our subject is programming and problem solving, right? I was given a problem to add two numbers. So I have shown you how to solve the problem with the help of an algorithm and the flowchart, right? And now I want to write in the form of a C program, which I want to execute and show you, right? I am clearing this. No. I am writing the program here. Program to add two numbers. So when you write the program, right? When you write the program, how do we write the program? Every C program will have a main function. You will start writing from the main function, right? Main followed by parentheses. There is no space in between. Main followed by parenthesis. Main is a function. How do you identify that it is a function? When a name is followed with a parenthesis, you can identify that as a function, right? Main followed by parenthesis. This is a main function. So every C program will have a main function from where the execution starts and terminates. Fine. So like how I said algorithm add, right? Similarly, I'm saying main here, right? When I'm writing the C program. Now to begin, right? I'll be using open brace. Fine. If I have an algorithm, . just map and then show the same thing here. Algorithm add equivalent to it is nothing but main here. And then when I say begin, I say open brace, right? What was the next step I had? Declare ABC. So how do I declare? ABC have to be declared as integers. So I have an integer data type. So I use int space, giving one space, followed by A, comma B, comma C. When I have multiple variables to be declared, I need to separate it with a comma, right? Int space A, comma B, comma C. Fine. What is the next step in algorithm we have seen? That is read A, comma B. So I have to accept some values for A and B. Let us say A equal to 10, semicolon, B equal to, let us say 20, semicolon, right? Next step is C equal to B. This I can write as it is in the programming also, right? C equal to A plus B. Now the output that is generated is available in C, which I have to print. So how I am printing it? With the help of print function. I have a print function here. Fine. Double quotes followed by \n. This is being used as a new line operator. Fine. This is being used as a new line operator. Means it will take the cursor to the fresh line so that your output will be available on the fresh line, right? So here you say that sum equal to, so in place of the value that have to be printed, you need to give the format specifier. For integer, what is the format specifier? %d. Double quote comma, you will be giving the variable of which value you want to print in place of this. Then you are terminating. This is what the program for the algorithm that I have written here, right? Print C and end. You can see mapping of the algorithm from algorithmic point of view to C program, right? This is a C program, right? So what did I do? First thing, I have declared the variables because I have declaration part, and then I have the initialization of the inputs that I have done it here. The next thing is calculation. I have done that same, and then the print output. I have the next step. So to print the output, I have print function. So I'll be using print function here. So here, what is happening in print function? Double quote. You know, this is a string value, right? Generally, print function will take print, printing the strings and all kind of thing. So here you have a double quote. Within double quotes, you can see there is a \n, which is said to be new line operator, right? New line operator. It takes the cursor to the fresh line. Then sum will be printed on the console. On the console, sum will be printed on a fresh line equal to, then in place of this %d, what is this %d? This is nothing but format specifier, right? Because print function is a formatted output console function, right? So for integer to print, we are using %d as a form specifier. For character, %c. For double, %lf. For float, %f. For strings, %s, like that. Okay. So c is an integer. For integer, we have the form specifier as for %d. So in place of this %d, what happens after double quote comma? Whatever the value you have or the variable you have, of which value will be printed here on the console. So what happens after the addition gets completed? C must have got the 30 as its value. Then the 30 will be printed in place of this %d. Okay, so this is what the output you'll get. Got it? I hope this has cleared all of you. How to transform an algorithm to program? Yes?
Yes, sir.
Yes. So now we can see, we can demonstrate this program to online GDB. Is that okay? Shall I erase this? Shall I erase this?
Yes, sir.
Yes, sir.
Now you take up some assignments also, which you have to rather, complete it as part of the lab now, because followed by this class is our lab for 2 hours, right? So I want you to complete these assignments, which I'm going to now give for you, rather, right? Write down, all of you, please write down. Anyway, this one you have to do it. Next one is, if let us say I'm giving you an assignment to perform subtraction of 2 numbers, what do? In place of this plus, you say minus, yes or no?
Yes, sir.
If I have to perform multiplication, what is that I have to do? In place of this plus, I should say into. Asterisk will be used as an into operator, rather, right? Asterisk. Asterisk you can see on the keyboard, right? This one. This is the asterisk for multiplication. And how do we perform division? With the help of slash, right? This is the front slash, this is the backslash. Backslash is being used as an escape sequencer here, you can see, right? Front slash is being used as a division operator, okay? Then you have mod operator also. If you want remainder as the result, you will be using this, right? Mod operator. Got it? So I am giving you some assignments here. Okay, note down. Write algorithm and draw flowchart. Subsequently, write a C program for the following. Write an algorithm, comma, draw the flowchart. Subsequently, write a C program for the same for the following. Okay. First one is addition of 2 numbers. Addition of 2 numbers. Second one is subtraction of 2 numbers. Third one is multiplication of 2 numbers. Fourth one is division of 2 numbers. Fifth one is finding the modulus. All of you have noted down? Yes?
Yes, sir.
Yes, sir.
Yes. So these you can do it, rather, right? I'll just show you here. Then now here I'm writing the program. What is the first step that I have to do? You just look at the program. I'm writing the first step is int a comma b comma c. Yes. Then what is the next step? Giving some values to a, then some value to b, then I want to add, so I'm adding here using this instruction c equal to a plus b, then the output which I'm going to print, right? Sum equal to, I say percentage t, after double quote, comma, the value which I have to print is c. Right. So now I will save this project as addition of 2 numbers. I'm giving add 2 numbers and then saving it. I have to choose the language here. I have to choose the language here. C as the language I have chosen. Then I can go for run, right?
Sir, it has written 0.
Yeah. So basically return 0 is optional. Since you have int is the return type, you'll be mentioning. Fine. If you use void, it is not required. Okay. Fine. So you can see the output here, sum equal to 30. Can you see, all of you?
Yes, sir.
Yes, sir.
Yes, sir.
So like this, you can execute your programs after you write. Fine. So it is level 11 now. I wanted to give you some more programs by explaining their logic. Okay. Shall we take? So because we have 2 hours of time, no? We can write and practice. Okay. So I'm giving you some more programs here. You can take some more programs. Write algorithm, draw flowchart, and write the C program for the same, for the following, right? I'm giving you, in addition to those programs, simple interest. How many of you know how to calculate simple interest? Right? When a program is asked or algorithm is asked, okay, you mean you are asked to perform certain tasks, right? Then what will you do? First, you need to know the logic behind it. Fine. What is the logic? How do you calculate simple interest is what the logic behind this. How do you calculate simple interest? Simple interest equal to PTR by 100. Yes or no? This is the formula. Yeah, first you need to know the logic. The logic behind the simple interest is SI equal to PTR by 100. So first thing that you need to, this is called analyzation, right? Analyzing. This is said to be the problem solving technique, right? Fine. So the first thing that you do is what? When you analyze the problem, you need to identify the logic. Identify the logic. The next thing, what will you do? Identify the variables and constants. Fine. Identify variables. Then next, identify their types, variables type, right? What type of the value that these variables must carry. The next thing is identify the inputs. Next thing is the logic itself, right? Which you are going to implement. Next thing is printing the output, right? The result rather, right? These are the steps for any task. When a task is asked, first you need to identify the logic behind it. So the logic behind simple interest is the formula. The formula you know is SI equal to PTR by 100. Second step is identify the variable. What are the variables here? Variables are P, T, R, S, I. What is the next step? Identify their type. What could be its type? P, T, and R. See, this is principal amount. So rupees and paisa, time. This can also be float. Rate of interest can also be a float. And then obviously SI will be a float. So you can consider as float, right? Float data type. So next, that is the next step that you have done. Next thing is identifying the inputs. What are the inputs in this? PTR are the inputs, right? What is the next step? The logic, the formula itself, right? Then print the result. What is the output which you are going to print? That is SI. So float is another data type, right? can use FLOAT P comma T comma R comma SI. You can declare like this. Okay.
Sir,
Yeah.
is it float?
Yes.
Float, sir. What is it, sir? Float.
You're not audible. Can you repeat the same?
Is that float? FLOAT.
Yes, FLOAT. Yeah. Before you do it, I would like to take one more session, fine, on data types, continuing the same. Then I'll give you 1 more hour for completing your assignment as part of the lab. Okay. Shall I continue with one more topic here? I wanted to explain you data types and operations in the same session today. Is that okay to all of you?
Okay, sir.
Yes, sir.
Yeah, I'll take half an hour, not more than that. Then you will be allowed to execute the programs, right? By writing them. Okay, now I wanted to discuss data types, okay? When you're starting any programming language, right? Any language, if you want to learn, before you learn, there are certain things which you need to know. Then you can probably get expertise in the same. I'll start from the scratch, right? Let us say, for example, you want to learn English language. Fine. Let us take an example of how to learn English language. What are the steps involved in learning the English language? First, you need to know the alphabets. Listen, once you know the alphabets A to Z, what will you do? You will be start framing the words and try to understand the words and their meanings. Then what will you do? You then start framing the sentences using these words, which gives you certain meaning for the same. Then you start writing a paragraph by combining these sentences. So once you are able to write paragraphs, then you say that you got expertise in English like language, right? Similarly, if I have to learn, let us say, C language, how to learn C language? The first step that you do is you need to know the character set. You need to know the character sets of C language. Okay. So here the character set is based on ASCII, American Standard Code for Information Interchange, right? So this carries, alphabets. What it carries? It carries alphabets, English alphabets with lowercase and uppercase. Then you have digits 0 to 9. Then you have special symbols which you can see on the keyboard, right? Which you can see on the keyboard. At the rate, equal, comma, blank space, all that together. So all that together are about 128 characters, right? So this American Standard Code for Information Interchange, developed by Ascii people, American National Standard of Institute, fine, who has provided us 128 characters, including alphabet, digits, and special symbols. The same we are going to use in our C program, in our C language, right? To represent all its programming constructs. So once we know the character set, then what is that we do? We need to understand what are the variables, what are the constants, what are the keywords, right? As part of C language, right? Keywords, variables, and constants, right? So once you understand this, then using this keywords and variables, constants and all, you will be framing an instruction. Every line in a program is said to be an instruction, right? Then you combine these instructions, it becomes a program. Got it? That is what I said at the beginning, the definition of program. Program is a set of instructions, but instruction is a set of keywords and variables, constants and all. But then they are all based on a character set, right? Given by Ascii, which carries all English alphabets, lowercase, uppercase, digits 0 to 9. Then you have special symbols that you can see on the keyboard. What all the special symbols? All together are 128. Got it? So here now the interesting thing is keywords. So what are the keywords? All right. Keywords in C we have 32. How many keywords we have? 32 keywords, right? Got it. So this 32 keywords will allow you to write the entire C program. Fine, without keywords you can't write a program. Got it? So declaration and all programming constructs, including conditional, unconditional statements, structure, arrays, files, data structures, all that stuff, right? I will be able to represent all the programming constructs of the programming language C using this 32 keywords only. Fine. So what are the 32 keywords? If I see, I have auto, break, continue, right? Do, else, for, int, char, float, etc., etc. Okay. So learning the programming language is nothing but learning the keywords itself. When I move the programming constructs from one by one, fine. When we take a transition from chapter by chapter, we will be seeing all these 32 keywords. So once you understand that what these keywords, why they are used, how they are used, and what is the use of the same, then you can say you are expertise in C language. Anything if you want to get expertise in, you need to put 3 questions behind. What for it is required? Fine. How it is used? Fine. Why it is required? Fine. How, what, and why. If you put 3 questions behind anything and you get the answers for the same, you say you are expertise in that. So, of course, learning our C programming language is nothing but learning the keywords itself. But I don't, teach you keywords taking one after the other. Instead of that, we will be, learning this from programming construct point of view, right? So we will be learning from the programming construct point of view, right? So all these keywords are going to be covered when we finish learning all the programming constructs of the C programming language till our end of the program. Fine. So until the end of the program sessions, you can be able to see that all these 32 keywords are going to be covered, right? So once you understand them by putting these 3 questions behind, you will be automatically get expertise in that, right? So we will be, of course, taking the transition from the chapter to chapter by, looking at from the programming construct point of view, rather, right? So variable, I've already used variable. The one whose value is going to be varied is said to be the variable constant is the one which will not be changed. For example, 100, 200 kind of thing, right? Then combining this all, what we frame the instructions, right? Combining all this instruction is what we say is a program. I hope this is clear to all of you. Fine. Step-by-step learning of C language, which we are going to start from today, right? So I'm clearing this. Now, I am now looking at, understanding this C programming language from the programming construct point of view, as I said. So there are 2 things before you start any programming language are more essential, as programming constructs. One is the data types. Another one is the operations. Got it? So any programming language, it could be C, C++, Java, Python, anything. When you want to learn any programming language, before you start learning, you need to know that what data type that this particular programming language is offering for you, and what are the operations that you are allowed to perform on the same, right? So here, as I said at the beginning, that in the computer, everything is data. You give data, and the programs is nothing but sort of instructions which are going to process on the same, nothing but the data, and then it produces you data. So everything you see right from the beginning till end is nothing but the data, right? You give some data and which will be processed, and then you will be given us an output. So when entire thing is the data right from the beginning till end, then we need to know what type of data it is. Because data, when you are start embedding, it could be of all kind, rather, right? When it is lot of data when being stored in the computer, then it is highly difficult for the computer to pick it out when you ask for a particular thing, right? So if it has been represented with some kind of data type, then it will be easy, fine, in order to locate the same. So that's the reason why where data types comes into being. So data types and data structures also sometimes we call it as, right? There is a difference between these 2. Of course, I'll discuss in the subsequent classes. Fine. Then the set of operations. So I wanted to see here what data types that C language is offering for you first. Okay. We have built-in data types. Then we have user-defined data types. All of you, please note it down. And then I have derived data types. Under built-in, I am having integer, character, char. Then I have float. Then I have long, right? Then I have double. Long int or long as a long int. So how many? You can see there are 5 data types, right? Integer, character, float, long int, and double. These are coming under built-in. Why I am saying it is built-in? Because they are readily available for us. You can directly use it, right? And out of which I say this 3, int, char, and float as preliminary data types, right? I call this as preliminary or primary data types. Okay. And if you can see long int is derived from integer, right? Int is a short int or int. So from where the long int is derived, and double is derived from float. Fine. Okay, then coming to user-defined data types. Under user-defined data types, we have structures, we have unions, we have functions, we have enumerated data types. Under derived data types, we have arrays and pointers. Okay, so these are the data types that are being offered by C language. Anyway, first we will see built-in data types. Okay, shall I erase this?
Yes.
Yes, sir.
Yeah. Now looking at built-in data types. Data type and storage or memory in bytes required. Okay, and value ranges. I can say int. When I say int, it is nothing but short int only, right? And I can say it is a signed also. All are same. If I don't give sign, default it takes signed only. Short int. If I just say int, it is nothing but signed short int only, right? So it occupies how much memory? 2 bytes. Now coming to what is byte. See, the entire memory is going to be represented in the form of bytes. Okay, so 1 byte equal to 8 bits. How many bits? 8 bits. And what is a bit? 1 bit is nothing but 1 or 0, right? Fine. Because our computer is represented with the help of binary number system, right? So integer requires how many bytes? 2 bytes. And what kind of value that an integer can hold, that you need to know, because if I give more than the range, it will not be accepted rather, right? So the range of value that it accepts is minus 2 power 15 to plus 2 power 15 minus 1. If I represent the same in decimal equivalent, it is minus 32,768 plus 32,767. Got it? Now, if I want only the positive values, then I can say unsigned, right? Unsigned int or unsigned short int. Then it will also occupies 2 bytes, right? If I do not mention sign or unsigned, by default, what it is taking sign. Then the values of that variable can range between this, right? Minus 32,762 plus 32,767. But if I want only the positive values, I need to mention unsigned before int. Okay, so it will also take 2 bytes here, and the value ranges are between 0 to 2 power 16. So the decimal equivalent of the same is 0 to 65,000. Fine, 65,000, around 355 like that. Okay. Then if I want a variable to be character, I need to mention it as char. Char will occupy how many bytes? 1 byte. And what its value? Its value ranges between 0 to 127. Got it? How many characters we have? We have 128 characters, right? Coming from where? ASCII, right? Which we have just discussed before. So if I say character, a character is coming from the character set provided by ASCII, which carries how many? 128 characters. So values are going to be range between 0 to 127. If I want the decimal value, I should use float FLO80, and it will occupy how many bytes? 4 bytes, and its value ranges between -2 power 31 to +2 power 31 minus 1. But it carries both, Mantissa part and the exponential. It means the integral part and the decimal part, right? If I want a value of integer but more than this range, then I have to go for long int, right? I say long int. It will also occupies how much value? How many bytes? 4 bytes, and its value ranges between -2 power 31 to +2 power 31 minus 1, right? But if I want the same float value, but then more than this range, I should go for double, right? I should say double. So I'm writing here double data type. Double data type will occupy how many bytes? 8 bytes, and its value ranges between -2 power 63 to -2 power 63 to +2 power 63 minus 1. All of you have noted down? I hope this is clear to all of you.
Yes,
To all
sir.
of you? Yeah. So we have these set of built-in data types available as part of the language. Int, or if I say short int or signed short int, all are same. If I do not mention signed or short, by default it is signed short only. That's the reason why I just say int. Fine. If I want signed short int, then I just say int. So int will occupy how many bytes? 2 bytes, and its value ranges between this rather, right? If I want only positive values to carry, then I can go for unsigned int. So I need to specifically mention. These are all the keywords. Int, short, there's unsigned, char, float. These are all the keywords as part of the 32 keywords, right, of C, which it consists of rather, right? So when I say unsigned int, it will occupy how many bytes again? 2 bytes, and the value ranges between 0 to 2. It will occupy 1 byte. Its value ranges between 0 to 127. So character includes what? All lowercase, uppercase alphabets, and you have digits from 0 to 9, and all the special symbols that you see on the keyboard. Float. Float carries the decimal and the integral part, right? Both it will be there. So how much does it require? 4 bytes of memory, and its value ranges between this. And long int, if I go with, it will, if I want integer kind only, but then with an extended value range, then I should go with long int, right? I need to specify long. If I don't specify long, it will by default take it as short one, right? So if I take long and then space int, then I will be given 4 bytes of memory, and my value range will be more than the integer, right? If I want, a float kind of variable, but the value to hold that float variable should be more than this range, I can go for double. So if I say double, then it will occupy 8 bytes, and the value range is this one. Is this clear to all of you?
Yes, sir.
Yes. So next we'll
Sir,
see.
alphabets come under char.
Yeah. What is it?
Character.
CHAR means character. Okay. Character.
Okay.
All ASCII characters you can take when you declare a character as a variable. Okay. Includes lowercase, uppercase alphabets, and digits between 0 to 9, and all special symbols that you see on the keyboard, right? So next we will move on to, next we will move on to format specifiers. Okay. What is format specifier? when you are basically using different data types in order to make the compiler to understand what type of data it is, while we print and read it from the keyboard, we need the format specifier. So it specifies the data type. Specify the type of data to the system. Okay, to the system. So if I have integer, all of you please note it down, whatever I'm writing here. If I have, let us say, integer data type, the format specifier used is %d, okay? %d. If I'm having character data type to read or print, then the format specifier that I'm using is %c. For float, I should mention %f, okay? For long int, %ld. For double, %lf, %lf. For string, %s. Got it? And for memory address, if you have memory addresses to be printed, that we will see with the help of pointers, we will be using %u. Got it? For memory addresses, what is the format specifier? %u. Okay. All of you noted down?
Yes, sir.
Yes.
Yes, sir.
Yeah. So while reading and printing the values of different type, in order to notify the system what type of data it is, we will be using format specifier. For integer, we use %d, for character %c, for float %f, for long int %ld, for double %lf, for string %s, for memory address %u, %u. Okay. I'm erasing this. Now next we'll see the operations, right? Operations provided by C language. C operations or operators, I say, right? What type of operations or operators does this C provides for us? Before you start the program, you need to understand these two things: data types and the set of operations that are being provided by the programming language. So we'll see here some of the operators which are being provided by C language. We have arithmetic operators, we have logical operators, we have relational operators, we have bitwise operators, we have ternary operators. Okay, here I will give you, of course, a broad classification based on the type of operations. Then from another perspective also we'll see based on operands what kind of operators that are being provided by C. Only the segregation of the same will be doing it, right? So ternary operator or conditional operator we call it as, right? Then we have size of operator. Then we have comma operator. Under arithmetic operators, you can see plus, minus, into, divide, mod, and under logical operators, you can see logical and, double ampersand is being used as logical and double vertical bar. You can note down all of these. Double vertical bar. You can find this vertical bar on backslash top of backslash in your keyboard, right? So this is being used for logical or. Then you have logical not, exclamation. This is exclamation being used for not. Under relational, we have greater than, less than, greater than or equal to, less than or equal to, double equal to, not equal to, and single equal to, right? Under bitwise, we have bitwise and single ampersand is said to be the bitwise and. If I use double ampersand, it is logical. Single vertical bar is being used for bitwise or, and we have double greater than being used for shift right. Double less than is being used for shift left. And we have exclusive or cab. This is cab actually being used for exclusive or, okay. Then ternary operator, it carries 3 operands, okay. Before question mark, 1 operand, after question mark, 1 more operand, and then after colon, another operand. So you'll find question mark, colon, right? It works like if else. Then size of operator, basically in order to know the number of bytes that a particular variable or value is occupying, we can know it with the help of the size of operator. Then we have comma, right? So comma is being used to separate when you have multiple variables to be declared, or when you have multiple statements in a single sentence or in instruction, right? These are all the different operators that are going to be provided by the C programming language, okay? Under arithmetic, some shortcut operators like plus equal to, minus equal to. When you have the resultant operand and the left operand both are same, right? Then you can use shortcut operator like plus equal to, minus equal to, into equal to, divide equal to, mod equal to, right? These are some shortcut operators. Fine. Anyway, we are going to see all these operations when we progress it from our, chapter from one by one. When we are studying the same using the programming constructs of the C programming language, right? One after the other. Here, if I have to classify the operators, from the operand point of view, when you have 3 operands, then you say it is a ternary operator. This is your ternary operator, conditional. It's nothing but a ternary operator, right? If I classify the operators from operands point of view, then they are said to be unary, binary, ternary. Under unary, you find unary minus, increment, decrement, size of, and all kind of thing. Got it? Then under binary means when you have 2 operands. Under binary, you find all arithmetic operator, logical, relational, and bitwise. All these operators comes under your binary. Then ternary, when do you say it is a ternary? When you have 3 operands, right? We call it as a ternary. And conditional operator is said to be the ternary operator. That is question mark, colon, right? So anyway, we are going to study all these operations as part of our programming language when we progress from chapter to chapter, right? From the programming constructs point of view. I hope this is clear to all of you. Any doubts still here?
No, sir.
Yeah.
Sir, modulus symbol.
This one is the modulus symbol, right? You find dot on the slash, one above, one below. You can find this mod symbol on your keyboard, right? Fine.
Percentage symbol.
Percentage symbol, yes. That is itself the modulus, right? Which will give you remainder as the result. This modulus, what it does, it is also a division operation. After performing the division, it gives you the remainder as the result. If I use division, this is said to be division, simple slash. This will give you quotient as the result after division. Got it? This is the only difference. Division will give you the quotient as the result, okay, after division, but modulus will give you remainder as the result. That is the difference. So this is clear to all of you?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
I am stopping my class here, explaining the concepts. What is that I have explained you today? I just summarized the same. I have discussed the block diagram of computer today, okay, by drawing the von Neumann architecture and explaining the different components and their significance. Second thing, what we have discussed is, we have discussed what is an algorithm, how to write an algorithm, what is the significance of algorithm, right? And then what is a flowchart and flowchart symbols, how to transform an algorithm into a flowchart, and then what is a program, fine. So how to write a program when an algorithm is given, fine, or a flowchart is given, fine. Next thing what we have discussed is when we are learning a programming language in a stepwise manner, how we have to go about, right? We have seen there are 4 steps. First one is character set. The character set of C language is based on Ascii, American Standard Code for Information Interchange, right? Includes lower uppercase alphabets, digits from 0 to 9, and all special symbols consisting of 128 characters, we said. Fine. So next thing, once we understand the character set, because that all we can see on your keyboard itself, we can see on the keyboard, and we know the importance of the keys, of course, because we are using it for years together, right? So next thing is the keywords, right? The keywords which are being provided by C language are 32. Using these 32 keywords only, you are writing the very, very big programs of C as well, right? All the programming constructs are going to be represented with the help of these keywords only. So by putting 3 questions behind these keywords, if you can find the answers for the same, you will be expertise with the keywords. When you are expertise with the keywords, you are expertise with the programming language. So we are learning these keywords from programming construct point of view, right? From chapter to chapter, right? When we progress in our syllabus, right? We will be covering all these keywords. Then what is a variable and constant we have defined. Then what is an instruction. Then how the program is going to be written using the instruction that we have seen. Then next thing we have seen is what are the different data types and operations that are being provided by C language. So we have seen the taxonomy of data types, or the classification of data types into 3 types: built-in, user-defined, and derived data types. And then under built-in, we have seen in detail, we have about 5 built-in data types like int, char, float, long, double. So we have seen that when we use this data, how much memory does it occupy, what could be the value that it range with, fine, we have seen. And then when we are using these data types, then to read or print, in order to notify the system, we need to have the format specifier. So what are the format specifiers we have with respect to different data types? We have seen. The next thing that we have seen is the operators which are being provided by C. Like we have seen the different operators that are being provided in general: arithmetic, logical, relational, bitwise, ternary, size of comma, and all. Then we have seen from operand perspective. Operand perspective, we can classify into 3 kinds: unary, binary, ternary. So under unary, you can find unary minus, increment, decrement, size of, and under binary, you can find all arithmetic, logical, relational, bitwise. And under ternary, you find conditional operator, question mark, colon. And then comma is a multi-nary I say, because you can have multiple operand. When you are declaring multiple variables, separating it with comma, then how many operands you're going to have? Int space a comma b comma c comma d. So it's a multi-nary, I can say, right? It's a multi-nary kind of operator, right? Under multi-nary, only one operand, one operator you have, that is the comma. So this is what we have seen, which I have summarized for today. Again, right? So I hope this is clear to all of you. This is being recorded and available on your YouTube as well. Fine. If you find any doubts, you can probably again get back to me in the next class. But for now, for 1 hour, right, I want you to write the programs. I want you to write the assignments that I have given. What assignments I have given?
algorithm and flowchart and C program of a certain operation.
Yes. So I have told you here to